Hello friend, I am Naval. You are watching Code with Naval. Welcome to Java series part 70. In the last video we saw synchronization. In this video we are going to discuss deadlock. So let's first understand what is the deadlock and which situation create a deadlock. Deadlock in a Java is a part of a multithreading. Deadlock can occur in a situation when a thread is waiting for an object lock that is acquired by another thread and second thread is waiting for an object lock that is acquired by first thread. Since both threads are waiting for each other to release the lock, this situation is called deadlock. Here both threads are waiting for each other object lock. Okay, however, that's why here called a deadlock situation. Okay, let's see when create a deadlock situation. We will simply understand practically. Here I'll simply create one class and I'll give this class name part 70, and here in this class here we require a two lock. That's why here first we create a two object. Okay, here create a public static object class object. We will simply create a object, and this first object here first lock we give simply lock1 equal to new object. Okay, this one is the first, and let's copy this and paste this and second lock. Here we simply create a two lock. Now here we need to create a two inner classes. Let's create those two inner classes. We will simply create here a private inner classes, private static and class. This class name is the part 70 underscore 1, and this class extend thread class. Okay, this class extend thread class. Okay, let's simply here override run method. Okay, let's override here run method, and inside the run method we will simply create a synchronized block. Okay, let's create here synchronized block. Let's create here synchronized block, and this synchronized block hold this object lock1 object lock. Okay, in this synchronized block we will simply print one message system.out.println thread 1 hold lock1. Okay, and after this holding we will simply add this synchronized block in a sleeping state. We will simply add here thread dot sleep, and here we pass 100 millisecond, and this should be inside a try catch block. Let's add this inside a try catch block. After this sleeping, okay, we will again add one statement. Here we simply write waiting for lock 2. Okay, thread 1 waiting for a lock 2, thread 1 waiting for a lock 2, and here we call lock 2. Again we call one synchronized block. Again here we call one synchronized block, and this block call lock 2. This synchronized block already hold this lock 1. Okay, lock 1 object, and again inside this block we again call this synchronized block, and this trying to hold lock 2. Okay, and inside this we simply print holding. Okay, let's write here thread 1 hold lock 1, thread 1 hold lock 2. Okay, here we trying to hold lock 2. Okay, here we create a one class. If we run program, okay, let's create this class object, and let's see t1 equal to new part. Let's add here part and call this t1 dot start. Okay, we should write this inside a main method. Let's add here main method and copy this and add inside a main method. Remove this outside code. Okay, let's format this code, and here call t1 dot start. and here you can see if I save this and run this thread properly executed. There is no problem because here only one thread class acquiring this to log. But what if we create a same class and that other class hold first log2 and then try to hold log1? Okay, let's copy this class. Okay, let's copy this class and again paste here. This class name is a part. Okay, part 70-2, and here instead of 1 we simply first hold log2 and this thread 2 hold log2. Okay, then here thread 2 waiting for a log1, and inside of this log2 thread 2 hold log1. Here instead of log2 we try to access log1. Now you can observe here. Okay, let's remove this space, unnecessary space, and I'll explain this program line by line. Let's see, first run this program. Okay, this line also remove, then we can see all program. Okay, let's save this, run this, and here you can see here. Okay, let's create this second thread object also. We only created here first thread object. Let's add here second, here also second, and t2, and then first we start t1, then we start t2. Okay, t2 dot start. Save this, run this, and here you can see first execute this block. First t1 dot start, then execution start from here. This synchronized block hold this log1 object log. Okay, and this synchronized block have a nature, it can't release that lock until and unless all block execution not complete. Okay, then start executing, first line execute, then we put this block sleep statement, then we put this block sleep statement, then this second thread get chance and this second thread immediately execute, and this second thread also execute their first line, and this second thread also go in a sleeping state. Okay, then till that time this first thread sleeping time complete, and this first thread again execute this line, and after executing this line, this thread in a synchronized block try to access this log2, but this log2 already acquired this part 70-2, this class inside of this synchronized block. This one is already acquired that this synchronized block already hold this log2 object log, and this one is also trying to access that. Then till that time this one also complete, this sleeping time also complete, then this line execute, and this one is trying to access this log1, but this log1 is already acquired by this synchronized block, and until and unless this whole block not execute completely, this synchronized block will not release this log1 object log, and this will not complete because this inner block need this log2 object, and this log2 object acquired this synchronized block, and this synchronized block not release that because this one need this log1 object. Okay, this synchronized block waiting for this log2 object, and this synchronized block waiting for this log1 object. This one also can't able to release because synchronized block not able to release until and unless all execution complete. Okay, this one is waiting for a log1 and this one is waiting for a log2, and both not able to release their lock. That means this situation, when if we started our program now, if we start this program continuously, we don't restart our computer, it will continuously waiting for each other lock. Okay, so how can we resolve this problem? So we can simply, whenever we use a synchronized block, that time we have to take a special care, because this synchronized block can hold lock. Okay, synchronized, if we pass here object, then this synchronized block hold that object lock. If we change any single object, okay, let's change here any object. Instead of holding lock A, here we simply change, instead of lock B, here we change lock 1. Okay, let's save this and run this, and here you can see immediately all program execute. Okay, there is no lock acquired, this all program properly execute. Okay, but if we try to access lock 2, that is already acquired this other synchronized block, then it will again go in a deadlock situation. Okay, whenever we use this synchronized block, that time check properly and implement properly this synchronized block, because this synchronized block, it's there possible to create a deadlock situation. So is there any way to avoid this deadlock situation? So we have a few points, we put here few points, so we can't solve deadlock, but we can avoid to generate a deadlock. Okay, how to solve deadlock? Deadlock cannot be completely resolvable, but we can avoid them by following some rules. Okay, we have to follow these rules and we can avoid deadlock situation. First one is avoid a nested lock. We have to avoid giving a lock to multiple threads. This is the main reason for creating a deadlock situation. It normally happens when we create a lock for a multiple thread. When we create a lock for a multiple thread, that time if we share one object lock with a multiple thread, that time it's possible to create a deadlock situation. Then second point, avoid unnecessary lock. Only lock should be given to the important thread. If we give a lock to unnecessary thread, because that also create a deadlock situation. If we provide a lock in every thread, then it will also create a deadlock situation. Okay, then third one is using a synchronized keyword. When use a synchronized keyword, take a special care. Synchronize make a thread safe, but it hold lock. Whenever we use a synchronized keyword, that time make sure this synchronized keyword not create a deadlock situation. Okay, you can see in this example here also, because the synchronized keyword, because this synchronized block deadlock situation create. Okay, and what is a starvation? Here we have a 1 crore thread. One thread have a low priority thread, and other than one thread, all thread have high priority thread. In this situation, let's consider we have a 1 crore thread and all high priority thread take at least 10 minutes. In this low priority thread get a chance, but when it will get a chance we can't say. It will get a chance after 1 year, it will get a chance after 2 years. Okay, that's why there is a difference between a deadlock and starvation. Deadlock is unresolvable, and in a deadlock two threads waiting each other forever. But in a starvation, some thread executing but few threads have a low priority. Those threads execute, but when those threads execute we can't say. Okay, in this video we understand what is the deadlock, when deadlock situation create, and how can we avoid a deadlock situation create. Okay, then what is a starvation and what is difference between deadlock and starvation. We will see next topic in a next video. Till that, bye bye.